Hello students, today we will study some basic concepts of chemistry, theory part 2. Disclaimer, the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. The topics that we are going to cover today are chemical equations and stoichiometry, limiting reagent, Dalton's atomic theory, law of chemical combinations, equivalent weight, and then we'll sum up it with the summary. Okay, chemical equations and stoichiometry. So what do you mean by chemical equation? So I would more appropriately, I would say it a balanced chemical equation. So a balanced chemical equation is that equation which has suitable stoichiometric coefficient such that the number of moles of reactant and products is balanced. So that is the thing to be kept in mind. Now, if we talk about the chemical equation utility, then it tells about both the qualitative and quantitative information. So what is the meaning of this? So suppose you are forming ammonia with the help of nitrogen and hydrogen. Then by writing the balanced chemical equation, first of all, you will be able to know that what mole of what will give what mole of the number of ammonia. Okay, so you are able to quantify the number of the moles or the number of the molecules, right? At the same time, what we are able to identify is the atoms that are there in the reaction or the compounds that are there in the reactions or the species that are there in the reaction, and that also in a very simple manner. So a chemical equation makes our chemistry life very easy. So stoichiometry deals with the calculation of masses of the reactant and products involved in a chemical reaction. The same thing is mentioned here, and the numeral used to balance is called as the stoichiometric coefficient. So what is stoichiometric coefficient? So they are basically the numbers that we put in front of the chemical species so that the chemical equation that we have becomes balanced, and the number of reactant the number of molecules of reactant species equals to the number of product molecule species. Clear? Okay. Now for the stoichiometric calculation, the mole relationship between the different reactants and products are required. The mass, the mass volume, the volume relation can be obtained between different reactant and product. Means by knowing the stoichiometric coefficient and your chemical equation, both of them I would say, we are able to know the different reactants and products. So what is the mass relationship? What is the volume relationship? What volume of what? Which means the reactant volume and the product volume. So all we are able to know with the help of this your balanced chemical equation. What is limiting reagent? So the substance or the species that is completely consumed in a reaction is called as the limiting reagent. So it determines the amount of product. So basically we are talking about that species which is present in less amount, right? So the reaction does not go to completion for the other reagent that we have. So that is the thing which is called the limiting reagent. And the amount of limiting reagents will correspond or will help us to know the amount of product that will be formed. So next thing is reaction yield. So the reaction yield formula is given by actual yield divided by the theoretical yield multiplied by 100. So what does this mean? So basically when we do a reaction, we do get the product, but that product is not up to or not according to our expectation, right? So the expected value is in the denominator and the actual value that we got, means after the reaction, the value which we got is in the upper part and multiplied by 100. So this thing is same as the percentage part, right? In the case of numbers, so you do perform for the exam, you are going for the complete number, but you get the number which is of course sometimes equals to the number that is the total, but more often you get number that is less than that. So you divide the number which you got, divide by and in the denominator you put the thing which is the total and multiply it by 100 and you get your reaction yield. So this is the same thing that is mentioned here. So this is the theoretical yield you have put here. which we have expected, the actual yield which we got it practically from the reaction, that is multiplied by 100, and that gives you the reaction yield. Clear? Okay. Now in stoichiometry, two quantities of two or more reactants are given. The amount of products depend upon the limiting reagent. So this thing is again mentioned here. So if you are having one reagent in the less amount, then the reaction will not proceed further, and the one which is in the less amount will determine the product, and that thing is very, very clear. Okay. Moving on to Dalton's atomic theory. So John Dalton was the one who gave the first atomic theory in 1808, and the main postulates of the theory are that atoms are hard, dense, smallest indivisible particle of matter. So what do you mean by this? By this we mean that your atom cannot be divided further. So it is written indivisible, and they're hard and dense enough for that reason. Okay, so for that reason we can't divide it further. So this was the idea of atom that was given by John Dalton. Second thing he told that it is indestructible, means it cannot be say broken down or decomposed into smaller parts. So it is indestructible and they cannot be destroyed in a chemical reaction. Third point, atom is the smallest portion of matter which takes part in the chemical equilibrium. So this is the point that makes our chemical equation also. So whenever you see the chemical equation, you see that that part is not, so if you're taking nitrogen, you will get the same number of nitrogen on the reactant side and the product side. So this thing is given by this point, that the smallest portion of the matter will take place in a chemical reaction because it does not broke down further. Clear? Now these atoms, this indestructible atom, this indivisible atom, this small portion of this matter, they combine with each other. Okay, they combine with each other to give the compound that we are looking for, and they do these things, these reactions, in the simple whole ratio number. Okay, simple whole number ratio. Okay, so simple whole number ratio, like if you are just combining your nitrogen with hydrogen, so N2 plus 3H2 gives us 2NH3. So the ratio of nitrogen to hydrogen will be 1:3, right? So that thing is mentioned here. So this is the simple whole number ratio. Now next thing is very, very important, that atoms of the same element are identical in mass and chemical properties. So if you took an atom, right? If you took an atom and if you took atom of that species, another atom of that species, you will find that these two atoms have the same properties. Both their physical and chemical properties are same. Either about their mass, either about their reactivity. All things are what? All things are identical for both of them. Now, chemical reaction involve reorganization of atoms, and these are neither created nor destroyed in a chemical reaction. So whenever you do a reaction, what we simply do is reorganize these indestructible atoms here and there to get our compound. Okay, and these atoms are not destroyed in a chemical reaction, means you will not see a nitrogen nitrogen atom getting converted to oxygen atom. Yes, there are reactions which do show such properties, but for now you can just assume that whenever we do a chemical reaction, we don't get a different atom from the starting atom, right? So you can't get nitrogen from oxygen, or you can't get say hydrogen from helium. If that was the case, then that would be wonderful, right? So we could be able to create any other element we want by this chemical reaction. Anyways, we will move now to laws of chemical combination. So the combination of elements to form compound is governed by the basic laws. So what are those laws? Law of conservation of mass given by Lavoisier in 1789. Then it says that the total mass of reactant is equals to total mass of the product. So suppose if you have 180 grams of reactant, then the mass of the product that is formed is 180 gram also. Okay, if it goes to complete reaction, then so in case it does not go, then the lost mass of the reactant is equals to the total mass of the product. So it is very, very obvious to understand. Next is law of constant composition and definite proportion, which was given by Proust in 1799. So it says that if you are taking the same compound, then the elemental composition or the elemental percentage is same for each element, right? So if you are taking, suppose you are taking ammonia, you're taking water, you are taking suppose sugar, or you are taking glucose, for each of this the content or the percentage of each of the element is same, right? Next is third is law of multiple proportion, which is given by Dalton in 1803. What do we get from this? So it says that if we have an element, if you have two elements, and those two elements can combine to form two different compounds. Okay. Now, if this is the case, then they do so in the simple whole ratio number. So what is the meaning of this thing? So let us look at an example here, which is the formation of NH3 and N2H4. So you can see very clearly, this is your NH3 and this is your N2H4. Now if you look here, you will see that the nitrogen has one coefficient here, here it is 2. So see, this ratio is simple whole ratio 1:2. And what is the ratio in between these two? It is simply 3:4. So it is clear to you. So you can just see it here also. And one more thing, this nitrogen requires how many hydrogen? So this requires 3 hydrogen, and this nitrogen requires two hydrogens, right? So if you just take this empirical formula, so one nitrogen will require 2 hydrogens. So this is the ratio that we get, it is 3:2. Okay. So the same thing is written for a given mass of an element, the masses of the other element are in the ratio of small whole number. Clear? Okay. Now next is law of equivalent reciprocal proportion by Richter in 1794. So it says that when two different elements combine with a fixed weight of third element, the ratio of their combination will be either be same or multiple of the ratio in which they combine with each other. Okay, so suppose this element, this carbon, is combining with hydrogen also and oxygen also. And in this case, oxygen is combining with carbon also and hydrogen also. So in this case, we apply this law. Next is law of combining volume, which was given by Gay-Lussac in 1808. So this is very, very important law, and this says that if we combine two gases, then they combine they do in the small simple ratio by volume. Okay. So again, I'm repeating it. So it states that when a gas combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gas are at same temperature and pressure. Right. So this is the law of combining law by Gay-Lussac. Next is Avogadro law. This is also very, very important. So it says that volume of all gases and temperature and pressure contain equal number of molecules. So sorry, if it says that equal volume of all gases at same temperature and pressure should contain equal number of molecules. So if you are taking two gases and they are maintained at same temperature and same pressure, then in that case your volume is also same. You would say that the number of particles will also be same. So this is very, very important law. Clear? Next is atomic, molecular and formula masses. So what is atomic mass? So it is defined as the number which indicate how many times the mass of an atom of the element is heavier as compared to 1/12 the mass of a carbon-12 atom. So what do we do is we try to align our mass and see it how much it is heavier, that atom is heavier than the 1/12 of the mass of a carbon-12 atom. What is gram atomic mass? So this gram atomic mass should not be the mass of their atom. Example, gram atomic mass of hydrogen is 1 gram, but mass of hydrogen is 1 nu. So that is a different thing, right? So this is not same. This thing is not same. This is the mass of one atom, and this is the mass of gram. This is the gram atomic mass. Okay, so it is simply your atomic mass, a mass in terms of gram, and this thing here is the mass of hydrogen atom in terms of G, in terms of gram, and this is in terms of U. So this is the relative thing. This is the actual thing. Clear? Next is the approximate atomic mass of solid element except beryllium, boron, carbon, and silicon is related to a specific heat as. So if we talk about the atomic mass of element except your beryllium, boron, carbon, and silicon, so they are related to a specific heat as average atomic mass is equals to 6.4 by specific heat. So this is very, very important calculation, right? So it is from Dulong's and Petit's law of metal. So exact atomic mass will be how much? It will be equivalent mass into valency. Next, as most of the elements have isotopes, so the actual atomic mass is the average atomic mass of all the isotopes. So what does this mean? So if you look at the hydrogen, it has 3 isotopes. If you again look at the chlorine, it has isotopes, 2 isotopes. So this isotope, so if you take their actual atomic mass, so what will be their actual atomic mass? Now 2 isotopes are present. What we will do is we will take the average atomic mass of all the isotopes that is present there. So suppose your average atomic mass is calculated in this way, right? So M average is equals to M1R1, okay, where M1 is the atomic mass of that actual say isotope, and R1 is the relative abundance. Similar is for M2, R2, M3, R3, and then we have added this R1, R2, and R3, where R1, R2, and R3 are the relative abundance. This thing is mentioned here, and M1, M2, and M3, as I mentioned earlier, that it is for the atomic mass of each isotope. Next, moving on to molecular mass. So what is the molecular mass? Very simple. We have known much about atomic mass. So if you add the atomic mass according to the molecular formula, then the mass that is obtained is called as the molecular mass. Clear? Next is formula mass. So what is formula mass? So it is basically the sum of atomic mass of all the elements in the formula unit of the compound. It is normally calculated for ionic compound. So this thing is very, very, very important. So this formula mass is nothing but the way of calculation is same. The only difference is that this is calculated for ionic compound. So why do we have to devise it for different for a ionic compound? Because ionic compounds are not present in molecules, but they are present as what? They are present as ions, right? For that reason, what are we doing? We are taking the formula mass and not the atomic molecular mass. Okay. So the calculation process is same. Suppose you take NaCl, then you simply add 22.5, which is for Na, and 35.5, which is for Cl, and add both of this, and you will get a formula mass. So it is written here also. They have taken approximate value of 23, okay, for Na, and 35.5 for Cl, and that is the formula mass for the NaCl, because NaCl does not exist as molecule. Next is equivalent weight. So it is the weight of an atom or a compound which would combine with or displace 1 part of hydrogen, or 8 part of hydrogen of oxygen, or 35.5 part of chlorine by weight. Okay, so this is the thing. So suppose you are combining an element and it is replacing 1 part of hydrogen. Okay, so means it is forming monohydride. So that is the meaning of this. If you are combining with oxygen and 8 parts has been removed, so it is that thing. So let us see that. For example, it is calculated in this way. Atomic weight or molecular weight is given by atomic weight or molecular weight by n factor is equals to equivalent weight. Okay. What is n factor? So n factor for various compound can be obtained as, so if you are talking about acidity and basicity, then for HCl it can donate 1 H plus, so therefore n factor is 1. Right? Sorry, it can donate 1 H plus, so basicity of HCl is 1. If you talk about the basis, then its acidity is 1. So if you talk about acid, its basicity is considered for n factor, and if you talk about bases, its acidity is considered for n factor. What is n factor for salt? So it is the total positive or negative charge of ions. Okay. Next is n factor for the ion. So if you are taking ion, so n factor is simply the charge on that ion. So this is the thing. So if you calculate for Cl minus, you take the molar mass divided by the charge, that is -1. We take the mode. We don't take the actual value, because this is equivalent weight. It cannot be negative. Similarly, if you are taking the redox reaction, then the n factor is what? Is the number of electron lost by the molecule. Okay, so suppose Fe2 plus is going to Fe3 plus, then in that case your n factor will be 1. And for oxidizing agent, what it will be? It will be just opposite of that, right? That it is the electron that is gained by that molecule. Clear? So this is the example. Same example is written here. Fe2 plus is going to Fe3 plus. So N factor is 1 in this case. And if Fe2 plus is going to Fe, then 2 electron has been taken, and therefore N factor is 2 for this case. Clear? Okay. So if you talk about the equivalent weight of oxidizing and reducing agent, then this is given by molecular mass of oxidizing and reducing agent divided by electron gained or lost by 1 electron. Clear? So this is in general for the whole redox reactions. Now let us try to summarize this. So we have seen this thing that chemistry is a branch of science that deals with the composition, properties and interaction of all kinds of matter such as air, water, rocks and plants. So it is basically the composition thing that matters in chemistry. Now anything that has mass and occupies space is called as, it has mass and occupies space called as matter, and on that basis, on the basis of the physical substances, it can be divided into solid, liquid and gas. What is mole? So mole is basically the amount of substance that contain 6.022 into 10 to the power 23 particles. So it is that amount of substance and has a mass equals to gram atomic mass in case of atoms and gram molecular mass in case of molecule. Next is the percentage composition of any element or constituent in a compound is the number of parts of the mass of that compound that constitute present in 2 parts. Okay, so we have seen this. So if you're taking 1 mole of suppose NaCl, then the mass of NaCl is in 1 mole is what? It is 23. And what is the overall mass? It is 58.5. Then what is the percentage composition? 23 by 58.5 into 100. So that's simple, right? Now for a compound, the elemental percentage will always remain same because their ratios and the amount that is combining to give the final compound is always same. For that reason, your percentage thing will remain always same. Now moving on to units, we have seen 7 base units, that is mass, length, time and temperature, and they are expressed with numerals. Okay, they are expressed with numerals. Suppose we are taking 2 liters, so 2 is the numeral here and liter is your, it is your say volume. So it comes under length basically. So 2 meter cube, it is a derived unit. Clear? Next is significant figure. So they are basically the meaningful figure and they are the last digit whose value is known with uncertainty, right? The uncertain is indicated by writing the certain digits and last uncertain digits. Clear? In calculation, many of the times it becomes necessary to convert units from one system to another because we need accordingly, right? We need the calculation accordingly. So if you're dealing with large amount, we take the units which are large enough. Similar goes for the small amounts. Next, we have seen some concentration term, molarity, strength of solution, molality and normality. After that, we have seen a balanced chemical equation. What is a balanced chemical equation? So balanced chemical equation is one which has suitable stoichiometric coefficient such that the product and reactant moles are balanced. Clear? So next thing is limiting reagent. So if you know the balanced chemical equation and if you know the and if you have amount of substance for the reaction, then the one which is consumed first is called as the limiting reagent and it decides the amount of product that will be formed. Then we studied about the Dalton's atomic theory that atoms are indestructible. They cannot be divided further. They have not subparticles and they are atoms of the same element have the same type of properties, whether physical and chemical. And whenever the reaction is done, this atom rearranges to give the compound. Next thing is the combination of elements to form compound is given by following basic laws. So the laws of conservation of mass, laws of constant proportion composition or different proportion, laws of multiple proportion, laws of equivalent and reciprocal proportion, and laws of combining volumes, and at last your atomic molecular formula mass we have seen, right? Okay, then we have come to equivalent factor, which was simply m by, that is molar mass by n factor. Okay, so this was all for today's class. Thank you.